皆さん、こんにちは。10周年です、トライスイフト。おめでとうございます。始めましょう。Hello everyone, my name is Paul Hudson, and this talk is called Why is SwiftUI Like That? My job here today is to teach you some of the internals of SwiftUI, how it works inside SwiftUI. I've been using this thing for 6-7 years now, since 2019, and I find every time I look at SwiftUI, I find something new. I'm like, wow, this is cool. Wow, look at this choice. Wow, wow, wow. I love it. And so, I want to share some of my findings with you today, because I believe if you learn more about how SwiftUI works internally, you will therefore write better SwiftUI code. So, I have lots to get through. Let's begin. First, the easy stuff. You already know that SwiftUI has a 3-step layout process. What happens is a parent proposes a size to its child, roughly how much space there is available for the child. The second step is the child then chooses its size, and the parent must respect that size. And the third step is the parent positions the child somewhere in its coordinate space. So, 3 simple rules, but they unlock lots and lots of power. And they unlock lots and lots of questions. For example, what is the parent view? What is the child view? Now, when you're learning SwiftUI, this seems like a very easy question. We can look at some code together. We could say, well, maybe we have a VStack. And in the VStack is some text, and maybe an image, and maybe there's a frame modifier as well. And I asked you the simple question, what is the parent of that text view? Now, when you're learning SwiftUI, the answer seems very easy. You say, well, I can see right there, clearly it's the VStack. That's the parent view. It's the easy answer. It's the answer you can see, but it's also the wrong answer. The parent of the text view is the frame. Now, think it through. We have one view here, our simple plain text. We have another view here, the frame modifier around it. That's our original text. That is the extra space around the text we asked for, making 2 views. And this makes sense in the context of our 3-step layout system. We know the parent is responsible for positioning the child. That's how it works. And so, when that happens, great. But beforehand, this text view has no idea how to position itself. It can't make a frame for itself. That's the frame's job, to place it somewhere on the screen. And so, in this code here, the parent of the text is the VStack. And this is what allows us, by the way, to repeat modifiers. I have text hello here with a blue background, but I could say add more padding and a yellow background, and then more padding and a red background, and each time I'm making more and more parents around the child. That is how SwiftUI is designed to work. Now, you can see it yourself. Please do run this kind of code. Very, very simple code. It's an on-tap gesture saying, just tell me the type of our body. What actually am I dealing with here? And when you run this code, you'll see output like this. A whole bunch of modified content. And that inner one is our text being modified to contain the frame we asked for. And the outer one is the inner one with an on-tap gesture. So most of the time, when we're making modifiers, we are making new views called modified content, this thing here. This is a regular SwiftUI view, taking our content and whatever modifier we are attaching to it. It is not secret. It's not magic. It's not private. It's not surprise. This is public API from Apple we are allowed to use. It's right there in the code. Shift-Command-O, open quickly in Xcode, boom, find modified content, read about it. You can use it directly in SwiftUI code if you want to. It's there for us to use. You could, of course, make a custom view modifier. You have to attach a transform for your content somehow. I might say I want to have some large font for my text, for example. And then I can apply my custom modifier in SwiftUI code. Of course I can. This is very boring, very simple SwiftUI code. But remember, that modifier just creates modified content. We could make it ourselves. Here's my modified content. Use it like that. And these two pieces of code produce the same outputs. They're both doing the same thing. Just one, of course, is shorter to read. And this happens for all your SwiftUI code. Here's a moderately larger example, and that also has lots of modified content inside as it's being transformed for us by SwiftUI at compile time. But we don't want to write that. No one wants to write that. What we want to say is some view. Something will go back here. We don't want to say what it is. We want the compiler to know. We want SwiftUI to know. We don't want to write it. That's the power of some view, an opaque result type it's called. And here we have our text again with a frame, and that text has not changed. The text still has an exact frame around it, matching the size of its text. That is the text role. You cannot expand that frame. It's not possible. That is always frame. We then place a new frame around it, a second view. And this is fairly obvious, I think, visually, when you say, well, why don't we try and align the frame somehow, say top leading edge? And that's only possible because the text knows its size. It can move around inside the parent box we've placed it inside. So this is public API for us to use, not secret, not magic. Go and check it out. But not everything in SwiftUI is this easy to find. The really good stuff is hidden away slightly more. Please do open this URL. hws.dev/SwiftUI. hws.dev/SwiftUI. If you are lazy, here's a QR code for you. Don't be lazy. Type the URL, trust me. And when you do that, you'll come to a page on my site which gives you a terminal command you can run. And this is the xed command to open files inside Xcode, and it opens up two Swift interface files. This is as close as we can get to Apple's source code for SwiftUI. They have to publish small amounts of this stuff in order for us to be able to use SwiftUI. This opens it up for SwiftUI and the lower-level SwiftUI core framework for us to work with. And it's long, and it's hard, and it's complex, and there's lots of it, but that's OK. Please do read it through. It's full of really interesting stuff. For example, you will know in the very first version of SwiftUI, we made buttons like this. We would say there's a button with a label and an action like that. It's text only. And then iOS 14, a year later, Apple added the label view, so we could have a title and an image at the same time. Very cool. But then a few years later, they realized this was way too much code to type. They made a new button initializer that takes a title, an image, and an action all in one initializer. Much nicer. But then they did something brilliant. They backported that code to iOS 14. Years before it was made, they made it work. And how? You can find out in that Swift interface file. Here is the code for that particular functionality. You can see here it's an extension on SwiftUI's button. It makes a new initializer. That initializer has a title and an image and an action. And then inside the body is the same code we would have written. Make me a label with that title and image attached to it. And this works backported because Apple has a wonderful private attribute for Swift called always emit into client, which is an Xcode instruction saying when this is being built, do not copy it into the Swift framework, SwiftUI framework, copy it into our app binary directly. So, this also has some other really interesting things to explore. Please do poke around and see what you find. For example, you may have wondered, why does SwiftUI have multiple modifiers for the same thing? For example, we can say to any kind of view, here's your font. Or we can say to some text, here's your font. And they're different modifiers. One returns some view, one returns a new piece of text. And this is really cool, because it means if we say to some text, hey, you have a font of large title, it's being applied to the text somehow. Swift has to choose which one of those two does it want to use, the some view or the text version. And Swift's constraint resolution thing is very, very simple. It chooses the most constrained version every time, the most specific version every time, and that is the version applying to text. And this same kind of code is used for other text-based modifiers too. For example, when you have foreground style, or bold, or italic, they're all being applied to a text version of that same modifier. And this is awesome. But why does it happen? How does it help us? How does it even work in the first place? And I said earlier that when you apply a modifier, you are usually making a new view, a modified content view. Text, one view, text with a frame is two views. But it's not always the case. And you can see again in that Swift interface file. Here is a chunk of the code for the Swift text struct. And you can see a huge enum of modifiers that can be stored directly inside the text. What is its color? What's its weight, its kerning, its tracking, its rounding, and more. These are stored directly inside the text, not making new views. And so, when we apply modifiers like this, a foreground style, a bold, italic, whatever, they get absorbed into the text view directly, making just more text. And this is such a powerful feature of SwiftUI. It means you can make multiple independent text views, maybe one blue, one red, and then use string interpolation to combine them together into one longer text view that flows across lines correctly. And this only works because those modifiers return more text. And you combine one text with another text just fine. However, if you had said, actually, this first one has some padding, that's not a text modifier, that returns some view, that code will not work. You cannot interpolate some kind of view with some text. So, there's a SwiftUI working very hard for us. It's making those modified content things for us, and it's often having multiple overloads of its data, and Swift's choosing the right one at any given time. But it goes so much further. SwiftUI will take your Swift code and convert it into SwiftUI code. It turns your logic into views. And this is really down to the way the some view system works. We know when I send back some kind of view here. Why is it some view? Why not just a view generally? And the answer is this horror again. This large piece of information, this is what SwiftUI wants. It wants to see this data. It wants to inspect our views at a very, very low level and see what we have. But why? Why does it care that much what we have? Just show on the screen already. Well, imagine you have three views, like this. And you want to create a fourth view somewhere in the middle. What SwiftUI wants to be able to do is know exactly what the three previous views were. So when it comes to making the fourth view, it can animate them nicely out of the way, not recreating them, and only make the one view that's actually changing. And this comes down to the concept of identity. SwiftUI wants to understand at all times what every view is on your screen and where it is. So it can animate things and do as least work as possible. Now, sometimes we use explicit identity. We use the ID modifier. This is called this. This is called that. Whatever. But more commonly, we use a thing called structural identity, which looks like this. We could say, this is the third text view in the second VStack, for example. That's its unique identity, its location in our view hierarchy. And so we see logic like this. If say hello, text hello, otherwise goodbye, and if I ask a beginner again, well, what happens when that Boolean changes? What does SwiftUI do? Now, a common answer is, oh, it's gonna check the view hierarchy beforehand, check it afterwards, and see what's changed. That never happens. That never happens. They're describing a thing we might say is called view diffing. View diffing is where you go through this idea of here's before, here's after, here's before, here's after, before, after, before, after. This does not happen. This would be horrifically slow. You've seen how big our view hierarchies become, modified content by the 1,000. This would be too slow to work in practice. And the truth is, SwiftUI doesn't need to know. It has everything it needs right here. Remember, it can see your code. It knows what you're trying to do. It can see, well, we have this thing. Let's see what is inside. Look for yourself. Please, just look for yourself. Add this tap gesture modifier, see what comes out, and you'll find SwiftUI has taken your Swift code and made it into views instead. This output is this. We have conditional content now. Specifically, a conditional content of 2 text views. Our hello and our goodbye, our if and our else blocks. Now, it is underscored. This is now a private API. We cannot make this ourselves. It's done internally by SwiftUI. But it is encoding our Swift logic into SwiftUI views, which is awesome. So we have this code here. If say hello, one thing, another thing. And again, Swift has full knowledge of this code. It can see, well, look, here's the true case currently. The Boolean changes. Now I'll show the false case. There is no view diffing required. It's just going to change pathways from this path to that path. It's very, very simple. It's even cleverer when you do a switch case. For example, imagine a switch case where you have case A, B, C, D, E, F, 6 different kinds of view you could possibly show. And we'll put that inside a custom view state property that shows one of 6 different kinds of view. Maybe text, maybe an image, maybe a shape, whatever. We don't know, but different kinds of views here. If we then show that view state with the same on-tap gesture, what happens when this code is run? Here's the result. A whole bunch of conditional contents. This one here, for example, is it a text or an image? This one here, is it a circle or a rectangle? Around that's another one which chooses path A or path B. And around that's another one that chooses path A or path B. Hopefully you can see what SwiftUI is doing here. It's taken your switch case code and turned it into a binary tree, where it walks through the tree step by step to find the correct code to show. This is so clever. It's so brilliant. I think it probably caused Doug Greger to lose some years off his life. It's brilliant stuff, but it affects the way you write Swift code. So again, we have modifiers like this that usually create modified content. Not always, but mostly. Then we have now conditions that create conditional content. And this is brilliant stuff, and it's all being powered by SwiftUI's view system behind the scene. But just returning view isn't enough. It wants all those details. What kind of view here? Is it conditional here? Is it modified here? It wants all the details. And it's being powered by this view builder. This is the body property from SwiftUI's view protocol, and it marks your body property as a view builder. That's the one doing the transform. That's the one making your modified content. That's the one making conditional content for you, all by that view builder. But it's also where I see people make the most mistakes, where they start to write some really dangerous and bad and slow SwiftUI code. So Let's walk through an example. This is how conditional content is defined in the Swift interface file. You can see it has defined to have two generic type parameters, one called true, one called false, and they're stored differently. A true view and a false view. And this means at the code level, these two views are by definition different. They are not the same view. They're separate, always. So again, here's a little test view, a bit of code for you. It'll scale up based on some double we provide to it. Otherwise, just show some text. Very simple little test view. Then in my content view, I might say, well, are we scaling up or not? A simple piece of local state. And I'll change that. If we're scaling up, do scale 2, otherwise scale 1, with an animated tap gesture toggle. Very simple code. But it contains significant problems. Here is the result. So you're seeing the small hello SwiftUI fade out, and the big hello SwiftUI fade in. And then back and forward again and again and again. So they're fading, they're not scaling. Now remember, what's happening here? This simple if scale up thing here. The conditional content being made defines our two test views, true and false, as being different views. They are never the same view. This will be the true view. This will be the false view. What we're not seeing is an animation. We're seeing a transition as SwiftUI destroys one view and creates a new view in its place every time. Now, you might think, it's OK. I've just learned about explicit identity. I can tell SwiftUI these are the same view. Damn it! It will not work. You'll have the same problem, a same transition still. Remember, at the type level, they are defined to be different. You can attach modifiers if you want to, but they are designed to be different things. That's the way conditional content is built. This is the conditional content, that if-else block. And it contains all the work you were doing. And yes, sure, you've got ID here. But these two test views are still defined to be different, not the same. This is the problem. The view builder. That's the one adding the conditional content for us. So what if we did without the view builder? What if we take that same code and put it into a new test view property? Not body, just test view. The same code, though. If scale up one thing, otherwise another thing. Then we place that test view into our body property with the same animating gesture we had before. The same code, basically, and now the difference is very, very clear. You get a smooth scaling animation. SwiftUI recognizes they are the same view and animates them correctly and saves work behind the scenes, too. It's a much, much better version. All we did was remove the view builder. Because by removing the view builder, we removed the conditional content as well. It's now just pure Swift logic. It can recognize it's the same view both times. Now, these two are being read as the same view. And some folks don't like that. They go, wait a minute, that's clearly two different views on two different lines of code. This does not feel good. Why are they the same view? Well, think it through. Pretend you are SwiftUI. You're in the body property, and your third view is your test view like this. And you want to know what's happening to it. Well, it reaches that line of code, and it'll go off and fetch the property and evaluate your Swift logic. It is being videoed, you know, yeah? I've got to take a picture of every slide. It reads our logic, and then simply goes, well, right now, its scale up is true. It just takes the result of that and copies it into the view directly, as if it was always there in the first place. Much, much simpler, much, much faster. It's now pure structural identity. That's the third view. It's a test view. If it's scale up, true, false, whatever, doesn't matter. It's the same type in the same location. It's the same view. Now, no one likes the idea of having to copy their code out to properties again and again and again, but this is why it's so important to use that ternary conditional operator right in your code, to remove the if-else, to remove the conditional content, so it's all done directly for the same view type every time. That one will work correctly. That one will animate correctly at full speed and nice and smoothly too. OK, that's enough SwiftUI from me. I hope I've inspired you to be curious. Go and dig around in this code, see what you can find. Remember this URL, hws.dev/SwiftUI. Try it out, run the command. Come and see me afterwards in the questions section. I'd love to hear what you discover. And if you're using SwiftUI through tools like Codex or Claude or similar, please do try my free SwiftUI Pro skill. It'll help your LLMs write way better SwiftUI code. Trust me, this is good stuff. Check it out. 3, 2, 1, too slow. And next time Xcode struggles to build your code, I hope you feel more empathy. These result builders are doing very, very hard work for us indeed. Thank you.